Alright, so let's go back to R3, and the solution for us to do is we use the filtering. Alright, we filter out the 10.0.0.0/16 network. And for us to do that, we are going to use the IP prefix. Okay, so I'm going to call it as filter summary index 10. I'm going to deny the 10 network with a subnet mask of 16. Alright, and anything else I have to permit. Index number 20. Okay, so 20 will be permitting anything. Okay, less equal, sorry, there you go. So I have a small little mistake here. Okay, so filter index 20 permit 0000 with the subnet of 0 less equal 32. So this command here means that I'm going to permit anything else. Okay, so when I do a display IP prefix, you can see that I have the IP prefix over here. And what I'm going to do is I go back into my OSPF, and I'm going to do a filter policy with the IP prefix, and my prefix name is called filter summary. And when you do a filter summary, here we are going to do an import. Okay, right, so this is my filter policy. So once I filter the policy, I have to filter on both sides, which is on R3 and R4. Then I will have the route disappear. So as you can see that this is before I do a filter. Alright, so I have the RIP there. Alright, with the /16. Okay, and I will expect it will still be there. That's correct. So you can see that it's in router 4 because I did it on the router 3. Okay, so what I'm going to do is I'm going to do a same thing. Okay, so this is my IP prefix. I'm going to copy this, and I'm going to do it on router 4. Okay, router 4, and I'm going to apply it into my OSPF filter policy IP prefix, and I'm going to use a filter summary import. Okay, so when I go back into R5, those should be removed. The summary route should be removed. As you can see that I already removed it. And when I'm going to go back into R2, I'm going to do a trace again, 10.0.9.9. You should have no looping. Alright, so there you see it how I can actually solve this issue. I'm going to do another one. I'm going to do a trace to make sure that it's still working. Alright, so there's no issue on here. So if I go back to R3, display IP prefix, you can see that there's get denied. Alright, so that's all on this particular exercise that I show you how you can optimize the route. Okay, so let's continue our lab. So here we are going to look into the policy-based routing. So company A need to optimize its network and has the following requirements. So we have two requirements here. The first requirement is to enable R3 to forward traffic from 10.0.0/24 and 10.0.1/24. So which means that if I'm sourced from these two, I have to pass through router 3 and enable R4 to forward 10.0.20 to 117.16x0, which means that if I'm coming from the last part here, I'm going to go through here. And for us to do that, we have to use the PBR. Now firstly, for the PBR, we have to configure ACL to match 10.0.0.0 and 10.0.1.0. Once we match the ACL, we are going to configure the policy-based routing and apply the next hop to R3. And same go for the 10.0.2.0. So we have to configure ACL 10.0.2.0. All right, we match it, and if we match the source, then the next hop is a router 4. And for us to do that, all right, let's look into the solution here. So we are going to configure on R5, and firstly, we are going to use the ACL 2000, 2001, and 2002. So we are matching these three sources. Okay. Now, for us to configure the PBR, we have to use policy-based route, okay, and not route policy. Okay, so policy-based route, remember, is a forwarding plane decision making. Route policy is a control plane. So now I'm going to match ACL 2000, and my policy name is called LB. If I match 2000, which is 10.0.0.1, I'm going to configure the next hop as router 3. So on the node number 20, I'm going to match 2001, which is 10.0.1.1, and the next hop is 35.1.1.3. And finally, node 30, I'm going to match 2003 ACL. I'm going to send it to the next hop of router 4. And once I configure the policy-based route, I'm going to apply it into my local policy using a command called IP local policy-based route LB. Once I apply, I'm going to do a testing. All right, as you can see that when we do a source coming from 10.0.0.1, it will go into the 35. All right, that's router 3. And if I'm using 10.0.1.1, I'll go to 35. But if I'm using 10.0.2.1, it will go to 45. So this screen shows us the result. So let's jump into our lab and configure our router now. Alright, so let's go to the router 5. So before we start, this is my routing table on the router 5. As you can see that 172.16.0.0/24, I have two gateway, 35.113 and 45.114. Same go for the 172.16.20, I have two gateway. So let me do a testing. This is before I have the PBR, or policy-based route. So I'm going to use a source of 10.0.0.1. I'm pinging to 172.16.0.1. So here is actually going to 45, and if I'm going to use a 10.0.2.1, let's see where it's going. So it's also going to 45 as well. So it seems like it prefer to go to 45 for the routing. Okay. All right. So it's actually going to here. So now we are going to configure the policy-based route. So let me go into the router 5 and configure ACL. So first I'm going to configure ACL 2000, rules, permit, source. I'm going to configure 001 with 000255. That will be on ACL 2000. ACL 2001, rules, permit, source 10.0.1.1. Okay, and ACL 2002. Okay, let me have a look here. There's no ACL 2002, rules, permit, source 10.0.2.1.0.0.255. So when I do a display ACL all right, so I have 2000 that is having a source of 10.0.0, 2001 10.0.1.0, and 2002 having a 10.0.2.0. So my ACL is complete. Next, I'm going to configure the PBR. So we are going to do a policy-based route. Give us a name. Okay, that's my policy name, permit node 10. I'm going to match ACL 2000 if I match the ACL 2000, before that, let me show you here. This will be my action. All right, I can actually apply the next hop over here. Okay, so I'm going to apply IP address, and my IP address, the question requires us to send to the next hop here, which is 35.1.1.3, okay, which is here. Okay, then I'm going to continue from here with a node 20. Okay, node 20, if I match ACL 2001, I'm going to apply IP address next hop to the same IP address. Okay, and final one, I'm going to do a node 30. This time I'm going to match ACL 2002, and I'm going to apply the IP address next hop to the router 4, which is 45.1.1.4. There you have it. Alright, so I have all my policy is done already, and you can actually use this command, display IP policy based route setup local. Okay, so currently I don't have my local policy set up yet. I'm going to apply it, so I'm going to use IP local policy base route LB. Now it's complete, so I'm going to do a display one more time. That is my configuration. So as you can see that LB is my name for my policy base route. So that is the node 10, just now that I configured ACL 2000, and the next hop is 35.1.1.3, node 20 ACL 2001. Next hop is the same, router number 3. If let's say the match on 2002, which is a 10.0.2.1, I'm going to send them to 45.1.1.4. Alright, so let's just check if this is true or not. Let me do a trace 10.0.0.1 172.16.0.1. It will go into router 3. Alright, there you go. Alright, so that's the router 3, 3.5. If I go to the 1.1, it will go to router 3. There you go. And if I'm going to use 2.1, it will go into router 4. Okay, router 4 in this case will be a 45.1.1.4. There you have it. Okay, so we have just configured the policy based route, and this is how it works. And you also can use the display IP policy based route. You can see the statistic and the local. All right, so as you can see that we have forwarded, all right, based on the node 10. Alright, this is being forwarded based on node number 20, and this is being forwarded based on network number 30. Now remember that anything that is not matched by the policy based route, again it will go into the default routing table. Okay, so here we have complete the entire policy based route. So hopefully you understand the difference between route policy and the policy based route now. Alright, so let's conclude our PBR as well as the route policy. So early on we have discussed the principle on route policy and the PBR principle. Okay, and we look into the configuration. Now we are going to look into some of the troubleshooting on both the route policy and the PBR. Now first let's look into the route policy troubleshooting. Alright, so it's very important for you to know how the route policy work, so that you were able to effectively troubleshoot route policy. Now here we have two conditions here. A suboptimum route is discovered after a trace route operation is performed or the routing entry are queried. So if you still remember our earlier example here, we have the suboptimum path because of mutual importing, as well as because that we have the looping that is occur due to the way how the routing work, especially when you use summarization. So first, you want to check whether the priority is the highest. Remember that our preference. Alright, so make sure that the preference from OSPF into the RIP or OSPF, alright, into the ISIS. You know what is the preference, else then they will have a suboptimum path. Alright, we can use a route policy to change the preference. Check whether the route policy filter the optimum path. Alright, so if let's say you have filtered the optimum route, then you have to make sure that you use another way to make sure the path is optimum. Check whether the route policy is used incorrectly. Okay, so maybe you do some permit and forget about the deny, because there is always a implicit implied deny at the end of the route policy. Now the second condition is that a routing loop discover after traced operation is performed. So firstly, on the above here we have suboptimum. Now we have a routing loop. So again, check whether the route policy does not filter some route, else you will have a routing loop. And check whether the route policy does not match specific route. Check your ACL and check your IP prefix, and check whether the route policy is used incorrectly. Alright, so double check. Use a display route policy. Check for the inbound and outbound. Alright, check for the tagging. Check for the action on the permit and deny on your ACL. Now, all this is important when you do a troubleshooting on your route policy. Next, we look into the PBR troubleshooting. Alright, so on the PBR, we actually look into the example early on that PBR work on the forwarding plane. So if your local PBR does not take effect, most likely you have not configured this command, IP local policy based route. Alright, so once you configure your policy based route, you need to apply in the local policy, that referring to your local router. And make sure that you have configured your matching condition and apply condition, which is apply to your IP next hop. Alright, so double check on this, and finally do a display IP policy based route to check your configuration is correct as well as the statistic. Okay, so this will be on the troubleshooting on both route policy and policy based route. So next we are going to look into cases. So there are two cases here we are going to examine, case number 1 and case number 2.